when we look at pumps, the parts of the pump that fail most readily are in fact not parts that the pump manufacturer actually makes themselves. We make the casings, we make the impellers, we make the bearing housings and so on. But the two most common areas of pump failure are in fact in seals and bearings. So we've got to look at what causes those failures and how we might fix them. So, in particular, vulnerable parts are seals and bearings. These components are not our manufacturer. They are made by a supplier as a bought-in item. So the quality of those things is within our control, but we're not actually manufacturing them. Most pump parts are covered by the manufacturer's warranty, but in fact, the bearings and the seals, that's a commercial decision that you guys make, how much you warranty those items. The cause of failure needs to be determined, since merely replacing the bearing or the seal may not deal with the cause problem. So you've got to isolate what actually made that seal fail, what actually made that bearing fail, before you can have an ultimate fix on the product. Sealed for life bearings. That is, for me, an interesting subject to discuss, because whose life are we sealed for? When you break it down, a bearing is only as good as the lubrication that it sees. And in a sealed for life bearing, we've got a situation where we've got an inner ring, outer ring and balls and a cage to hold it in position. We then put in some lubricant, and then we put two seals on either side of the bearing, and we call that a sealed for life bearing. The life could be 5 minutes, it could be 25 years. So what does sealed for life really mean? It's all down to the quality of that lubricant. Bearing temperatures are an issue. If you've got your shaft that's misaligned, that will heat up the bearings faster than you've got an accurately aligned shaft. So we've got to look at the operating conditions. Are we unreasonably loading the bearings beyond their design point? Bearing failures are often quite complicated issues because the fit of the bearing rings inside the casing and onto the shaft are critical to the life of the bearing. Normally they're going to be a push fit onto the shaft and a sliding fit into the casing. And in that situation, that's giving the bearing the maximum opportunity to align itself and run smoothly as a rolling element. So we should be trying to avoid things like vibration and mechanical overload on the bearings, and we'll get more life out of them. When you replace the bearing, check carefully to see what bearing you're actually taking out, because the bearing ring will give you the size, the outer ring will give you a 6306 or 6308. That's the size of the bearing. But it might also have a C3 behind that, or a C4. That is the internal clearance in the bearing, which tells you what will happen if that bearing heats up. So a C3 clearance is larger than standard. And it means that the temperature that that bearing can sustain is a little bit higher than one that's got a standard clearance. So all these things you need to be aware of. Don't just put any bearing that happens to look the same. Make sure you're replacing with the bearing that the manufacturer included. Have a look for cross-location, have a look for Brinelling damage and so on. Because if you put a damaged bearing back, it's almost certain to fail. Here are some typical situations where bearings have failed. Here's our sealed for life bearing. Okay, and here you can see the seals, the seals which are fixed in the outer ring, which doesn't rotate, obviously, and the inner ring is the one that rotates. So there's a rubbing between that inner ring and the seal surface. And behind that seal is grease, and that can be high temperature grease or just standard grease. Look to the pump manufacturer's recommendation for the sort of grease that they use. Grease disappeared. Look at the state of the bearing. Bearings need lubrication. They're spinning maybe at 2,900 RPM, and those balls get hot without grease. This is sort of standard surface damage. This is Brinelling. That's what Brinelling looks like, because and this is in a barrel roller bearing. You can see that the barrel rollers have been stationary, but they've been fretting, they've been vibrating, and they've actually damaged the outer ring of the bearing. False Brinelling. False Brinelling is when we've got two pumps on the same base plate, but only one of them is operating. The one that's operating will cause a vibration, and the pump that's stationary has the potential to generate what we call false Brinelling in the bearings of the pump. And this is because the ball in the bearing of the stationary pump is in one spot. And if you vibrate that ball in the outer ring of the bearing, it will cause what we call false Brinelling. You can get literature for failures of bearings, and SKF is an international company. They are the sort of people that can give you advice on why that bearing failed. So we looked at bearings and why they might fail. Lubrication is nearly always the most common one, but overload is the second. So if you operate a pump away from best efficiency point, you will see that the load on the bearing increases. The further away you get from best efficiency point, the greater the radial load on the bearing.